we're going to look at the conjugate zeros theorem. What this theorem says is that if we have a polynomial with real coefficients, that means we have the coefficients are not a complex. If this polynomial has a plus bi as a 0, then its conjugate, a minus bi, will also be a 0 of this polynomial. So if you have a polynomial with real coefficients, the complex zeros, if there are any, will show up in conjugate pairs. All right, let's do an example of this. Here we want to find a fourth degree polynomial with real coefficients that has 0, 1, and I as zeros. All right, well, we know immediately that if we want to create this polynomial with real coefficients, we cannot just have I as a 0. I must come with its conjugate, which is minus I. All right, so what we can do is we can set up our polynomial with factors, each one of these zeros, plus the conjugate. So we have x minus 0 as a factor, x minus 1 as a factor, x minus I as a factor, and then x minus a negative I, so plus I. All right, and so that accounts for all of the zeros, including the conjugate, right, which has to be there because this polynomial needs to have real coefficients. Okay, and now to find the polynomial, we can just multiply all this out. X minus 0 is just x, x minus 1, and then I'm going to multiply these out first because I know that if we multiply two conjugates together, the answer is going to be real. So x times x is going to be x squared, x times I, negative I times x, those cancel. Negative I times I is negative I squared, and that can be written as x squared plus 1, since I squared is negative 1. All right, let's go ahead and distribute through the x. We've got x squared minus x times x squared plus 1. And now foiling this out, give us our answer. So x to the 4th plus x squared minus x cubed minus x. So first, outer, inner, last. And then just to make it look nice, we will rearrange it so that the highest powered term, or goes from the highest powered term to the lowest powered term. There we go. There's a polynomial with real coefficients with 0, 1, I, and negative I as zeros.